Hi, I'm Miss Hearn. Let's get started. In this exercise, we're going to solve a rational equation. Rational equations have ratios in them, or fractions. And here we have the equation 5 equals 21 over 5x minus 1 plus negative 4 over 5x minus 1 squared. So there are two things you need to keep in mind. First, you can't have any solutions that would make the denominator equal to 0. In other words, we have to solve for restricted values and exclude them. The second thing that we need to do is to find the least common denominator of any fractions and multiply by it on both sides. So let's get started. First, let's find the restricted values. Restricted values are values that make the denominator 0. We're not allowed to have 0 in the denominator because that causes an undefined expression. So we can make sure that we don't accidentally include any extraneous solutions by setting each denominator equal to 0. So in this case, we have two denominators, but each of them has a factor of 5x minus 1 or 5x minus 1 to a power. So the only way we would get a 0 denominator is if 5x minus 1 were 0. Adding 1 to the other side, then we have 5x equals 1, or x is 1/5, is the one real number that we know is not a solution to this equation. Now let's go ahead and find the least common denominator and multiply it on both sides of the equation. So when I say least common denominator, I'm just talking about an expression that is a multiple of each denominator, so the denominators will go in evenly and cancel out. Your least common denominator should have each unique factor, of which we only have one, 5x minus 1. Each unique factor raised to the highest power it appears, so we would use 5x minus 1 squared. Now I've copied down the equation, leaving space between the terms so that we can multiply 5x minus 1 squared on both sides, which has the effect of multiplying it times each term because we have to distribute. So on the right, we only have one term, so we multiply the 5 times 5x minus 1 squared. On the left, though, we have to multiply times each of these two terms, and it's like multiplying a whole number times a fraction. So it ends up, if you think of the whole number being over 1, the whole number ends up in each numerator, only the numerator. So I'm going to write it next to each numerator, 5x minus 1 squared. Now, what we hope will happen if we did everything right is our denominators will cancel out. So on the left, we still have 5 times 5x minus 1 squared. On the right, this first term has a 5x minus 1 in the denominator, the bottom, and 2 copies in the numerator. So if we divide that out, there's just going to be 1 copy left in the numerator. So we'll have 21 times 5x minus 1. Don't have to write to the first power. And in this last term, 5x minus 1 squared goes into 5x minus 1 squared once, and we have a negative 4 times 1, or negative 4 here. Okay, so what you have to do after the multiplying both sides by an LCD is just kind of regroup and think, what kind of an equation do I have now? Well, it might not be immediately clear, but once you multiply out this binomial, 5x minus 1 squared, you're going to see that you have an x squared in this equation, and this is going to be a quadratic equation. So we want to get it in standard form. Now, little tip. Get good at squaring binomials. What I mean by that is, instead of thinking of it as 5x minus 1 times 5x minus 1, which is good, this will work, and you just FOIL it out. But a quicker way is to do the following. It's a little rhyme. Square the first, square the last, multiply together, and double up fast. This will save you a lot of time and potentially some errors as well. So here's what I mean. Square the first refers to squaring the 5x, which is going to give you 25x squared. Square the last is squaring the negative 1. Anything squared is positive, so this is going to be positive 1. Multiply together is referring to multiplying the 5x times the negative 1, giving you negative 5x. And doubling that, double up fast, gives you negative 10x. So there we've squared our binomial very quickly. On the right, we want to distribute through the parentheses. So this is going to give you 105x minus 21 minus 4. Now that was on the right. Now on the left again, we're going to have to distribute through the parentheses here as well. So 5 times 1 times 25 is 125x squared minus 50x plus 5 equals 105x minus 25. Okay, so now we can clearly see this is a quadratic equation because the highest power on the x is a 2. We're going to get 0 on one side, so it's in standard form. So I'm going to subtract 105x and add 25 to both sides. Make sure to pay attention to which are like terms. Okay, so we are going to have a nice quadratic equation, 125x squared minus 155x plus 30 equals 0. All right, before we start applying quadratic methods to this equation, I noticed that these are some pretty big numbers and they all appear to be divisible by 5. So I'm just going to divide both sides by 5 just to make my numbers smaller. Divide both sides by 5. I want to do that in red here. Divide both sides by 5. Okay, 0 divided by 5 is just 0.
0 divided by 5 is 0.
My Siri is talking to me here. Okay, so let's see. So on the right we have 0, and then on the left 5 goes into 125 25 times. So we have 25x squared minus 31x plus 6. Okay, now we can either use the quadratic formula or factoring. Often with large numbers, I go ahead and use the quadratic formula. However, I think in this case, I'm just going to practice factoring so I can show you something called the AC method. So remember, this fits the pattern of a quadratic because it's in the form ax squared plus bx plus c equals a number, equals 0 rather. And so what I'm going to do is apply the AC method, which is a way of turning it from a trinomial factorization to a 4-term grouping problem. The AC method tells you to multiply a times c, which in this case is 25 times 6, which would be 150. And then you compare that number to b, which in this case is negative 31. And what you're looking for is factors of 150, so two numbers that multiply to give you 150. Factors, oops, scoot that over a little bit. Factors of 150 that sum up or add to negative 31. And it just so happens that 25 and 6, I notice, add up to 31. So if I factored 150 into negative 25 times negative 6, those factors would add up to negative 31. Now what you do in the AC method is a little different from other methods. Sometimes people mistakenly think you're going to write x minus 25 times x minus 6, but that definitely would not give you the trinomial we're looking for. No, what you do with these two numbers is to split the middle term, negative 31x. You want to split that into two terms. So this negative 31x we're going to write as negative 25x minus 6x. We still have our first term and our last term here. And we still have the equal 0. Now, why on earth would we want to do this? Because now we can use grouping. So what we do is we look at the first pair of terms and we say, okay, 25x squared minus 25x, those have 25x in common. If we factor that out, we're left with x minus 1. And negative 6x plus 6, whenever there's a negative in the leading coefficient, you want to factor out a negative. So here I would factor out a negative 6, which would also leave an x minus 1. You should always get the same quantity here and here if you did your AC method correctly, unless it happens to be a trinomial that just is prime, it's not factorable. But this one is. So factoring out then the x minus 1, what's going to be left behind is in the first term, we're going to be left with a 25x, and in the second term, a negative 6. So when we factor out the x minus 1, we're left with 25x minus 6 equals 0. Now, if you like doing another factoring, I always tell my students if they like a different factoring technique, go for it. But just whatever factoring technique you use, stick with it. Don't mix up the AC method with other methods because it's quite a bit different. All right, so now, why is it good to have a factored form when you're solving a quadratic equation? Well, because that means we're multiplying two mystery numbers together and getting 0. So one of them has to be 0 logically, right? So that would mean either x minus 1 is 0, so x is 1, or 25x minus 6 is 0, which would mean x is adding 6 over, we get 6, dividing by 25, we get 6/25. Now, it's very important to remember that we were solving a rational equation originally. So looking back up at the top, remember we said our restricted value was 1/5. Well, is this 1/5? No, we have 1 and we have 6/25. So our solution set contains 1 and 6/25. Those are our two solutions, meaning if we were to plug either of those numbers into the original equation, we would have a true statement. 1 6/25. So I hope you found this video helpful. If you did, please remember to like it. There's a link to the OneNote document that I'm writing on in the comments below.